In section 2.5 of this course, Solving Exact Equations, we are going to need to use partial derivatives. Partial derivatives are derivatives of functions of multiple variables, such as f of xy equals x squared y minus 3x squared plus e to the y. When we take a derivative of a function of two or more variables, we have to be specific about which variable we are taking the derivative with respect to. In this class, we will only need to be able to find first partial derivatives. To find the partial derivative of f with respect to x, we treat y as a constant, and then we differentiate with respect to x normally. To find the partial derivative of f with respect to y, treat x as a constant and differentiate with respect to y, remembering that y is an independent variable. I make a point of emphasizing that y is an independent variable because we get really used to the idea that y is a function of x. But when we are working with a function f of xy, x and y are independent of one another. Let's try taking some partial derivatives. Let f of xy be x squared y minus 3x squared plus e to the y. Find the partial of f with respect to x and the partial of f with respect to y. To find the partial of f with respect to x, we treat y as a constant. So going term by term, the y in x squared y is being treated as a constant. So it is just going to stay there as is. And then we are taking the derivative of the x squared. So that becomes a 2x, and we get 2xy. Then there is no y in the negative 3x squared term, so we just differentiate that normally to get minus 6x. Then finally, the last term, e to the y, has no x in it. So that's a constant with respect to x, and its derivative with respect to x is just 0. So the partial of f with respect to x is 2xy minus 6x. Then, to find the partial of f with respect to y, we treat x as a constant now. So the x squared in x squared y is going to stay as it is, and the derivative of y with respect to y is just 1, so that just gives us x squared times 1, or just x squared. Then, negative 3x squared has no y in it, so it is a constant with respect to y, so we get 0 when we take the partial derivative with respect to y. And finally, e to the y's derivative with respect to y is just e to the y again. So the partial of f with respect to y is x squared plus e to the y.